Good afternoon, everyone. My name is Scott Barstow, and David Peabody, myself, and other Alexandria, Virginia colleagues have started working together as the group Build Our Future to address how our built environment connects to our community's response to climate change. And thank you so much for joining us. We really appreciate your interest. Because of the German name Passive House, the Passive House standard, which is in the US, developed and administered by PHIUS, P-H-I-U-S, if I'm getting the acronym right, David.
Yes.
The Passive House standard has long been misunderstood by architects, developers, and the public in the US to only be applicable to houses. In fact, it's actually most difficult to achieve the standard for small buildings like houses. It's much less of a lift for larger buildings. And so we invited Datner and Trinity to join us to explain why that is with real world examples. We're focusing on this because about 60% of Alexandria's greenhouse gas emissions are associated with energy use in buildings. And we're hoping that this webinar will highlight another example of how architects and developers around the country are getting it right and putting up buildings that are truly net zero or net zero ready. And we believe the Passive House approach is simply the most efficient means of getting there. And this webinar is happening in the context of millions of square feet of new development now in the pipeline for Alexandria. Developers have a choice to build responsibly with high-performing buildings, or alternatively, hamstring our city's chances of reaching our 2030 greenhouse gas emissions goal of cutting our emissions in half. That's just 8 years away. Datner and Trinity Financial are going to show how they have chosen a responsible approach using Passive House construction with buildings that produce less than half the greenhouse gas emissions of buildings built to the current Alexandria Green Building Policy. Among the projects our panelists will discuss is 425 Grand Concourse, which just won top awards last week at the annual conference of the Passive House Institute US, including the Building of Excellence Award and Best Overall Building Award. So we're very happy to get the opportunity to hear more about this. We're joined here by Rachel Ehrlich, AIA Associate Principal with Datner Architects. Datner is a New York-based design firm committed to architecture that positively impacts our cities. In her professional life and as a climate activist and member of the Borough Council of Madison, New Jersey, Rachel believes that good design is socially and environmentally just. Next, we'll hear from Heather McKinstry, one of her colleagues at Datner. Heather's initials AIA lead AP CPHC. After completing her thesis on disaster relief housing, Heather's commitment to environmentalism and community-focused urbanism led her to work creating spaces for all New Yorkers while minimizing the environmental impact of new buildings. And finally, we'll hear from Christoph Stump, AIA Vice President of Design and Construction with Trinity Financial Services, a development company with a 30+ year track record of developing urban sites from New York to Boston with medium and large scale mixed use residential projects. Christoph manages all the technical aspects of development, including environmental, permitting, design, and construction. So with that, let me turn it over to Rachel.
Thank you so much, Scott. We thought amongst us that we would introduce ourselves all together at the top of the presentation so as not to break up the flow while we are sharing our slides. So I'll start. My name is Rachel Ehrlich. I'm an associate principal at Datner. As Scott mentioned, I have 18 years of experience in designing energy efficient multifamily housing with a real focus on large scale mixed use, high performance, affordable projects, such as the 4 Passive House projects that we're going to share today. And also, as Scott mentioned, I'm a council member in the Borough of Madison, New Jersey. It's a small town of about 16,000 residents. This year, we adopted a climate action resolution, and we're working to cut our energy costs and reduce our greenhouse gas emissions to be in line with the New Jersey State Energy Master Plan. Like Alexandria, the majority of Madison's emissions are driven by buildings. So I'll jump into the presentation in just a minute, but let me turn it over to Heather and Christoph first.
Sure. I'm Heather McKinstry. I'm an associate at Datner Architects.
I'm a leader in our sustainable practice group, and I was the project manager for the building at 425 Grand Concourse. I started working on the project when it was in design in 2017 and worked on it through the end of construction, and we had our ribbon cutting on Wednesday.
Yeah, thanks, Heather. I'm Christoph Stump with Trinity Financial. I was introduced already. I basically oversaw all the technical portions of 425 Grand Concourse that we're going to see. And that's been a long process, and partially because of issues that are outside of most issues are outside of the energy efficiency portion that we're going to focus on today.
Okay, so we've divided our presentation into two parts. We're going to focus on architecture and design in the first segment, and then Christoph will discuss more of the finance and the developer's perspective on Passive House. So I mentioned that the 4 projects that we're going to share today are large, mixed-use, affordable projects. That means that the apartments that we're showcasing today are income restricted at various affordability levels. But what we want to focus on today is how the Passive House standard offers a systematic way to build high-quality homes in urban settings with really unique characteristics that help differentiate them in a crowded housing market. So Dattner Architects is a New York City-based firm founded in 1964. Our focus is on civic architecture. So by that, we mean that we design housing, healthcare facilities, schools, libraries, parks, transit and recreation facilities, as well as infrastructure. And these projects really reflect their users, the neighborhoods that they're in, our client's mission. And with our projects and our work, we continually improve, we seek to improve the fabric of our city. So we'll briefly recap the 5 principles of Passive House. I think maybe our audience today is somewhat familiar with Passive House, but here we've used some snippets of our design for the 425 Grand Concourse project to illustrate some of these principles. So that includes continuous insulation and minimizing thermal bridges. It means we have a very tight envelope that reduces the flow of energy from the inside to the outside. We try to, in all of our external and envelope details, we try to have thermal isolation, so we're not losing energy through the structure and the skin of the building to the outside. Passive House buildings have energy recovery ventilation systems, which means that as we exhaust the stale air from the interior, we capture that energy and we use that energy to preheat or pre-cool the incoming fresh air. So the air streams aren't mixed, but we capture the energy from the exhaust and very efficiently use that to temper the fresh incoming air. Because of both of these features, we have minimal space conditioning systems inside. So the building is designed to be high performance without excessive or oversized heating and cooling systems. Passive House projects have high performance glazing, which both insulates the interior and also prevents solar heat gain, and a continuous air barrier. So there's a high level of air sealing, so there's no uncontrolled air leakage out of the building, and it helps us preserve that well-conditioned, draft-free, comfortable interior. So these features save energy and they permanently insulate owners and renters from the price shocks of the fossil fuel market that, are causing us so much upheaval and inflation right now. But they do a lot more than that. So the beauty of offering Passive House and sustainability features in a market rate product does a lot of things for a developer, including helping you to differentiate your offering. It makes sales quicker, you can get better rents and reduce vacancy. You can retain tenants because it's a superior product. So, with the features that we're going to talk about today, you're demonstrating that your building, your project is innovative, sustainable, forward-thinking, and it really defines the company brand as one that looks to the future, both with, in terms of thinking about energy and thinking about how the residents that you're appealing to want to live, the lifestyle they want to have. So along with the reduced energy bills, the low energy consumption of Passive House buildings make it easy to supply some or all the electricity through clean on-site power sources, such as solar panels. And then when the power is out, the building is highly insulated to permit sheltering in place. So we've got this energy savings that both reduces our bills and makes, healthier, resilient buildings. Looking beyond those increasingly frequent extreme circumstances now that residents of the Eastern Seaboard and around the country are experiencing, passive house buildings, I would say most striking feature is the greater degree of comfort, health, and interior quality that they offer. Passive house creates a really comfortable home with even temperatures and reduced draftiness. And those high performance windows and heavily insulated walls and doors also greatly reduce exposure to street noise and other outdoor sounds. A really striking feature of a passive house home is the superior indoor air quality. When you walk into a passive house home, you can tell the difference. The air is clean and fresh. It's constantly filtered, and it feels like you're sort of have this sort of clean air sanctuary of high indoor air quality in your home. This is a health benefit that can be positioned either as a luxury or, as it often is in New York City where we work, it's offered as a remedy in areas that have struggled with health equity and environmental justice issues. In terms of fitting out and equipping these apartments with electric induction ranges, you're not burning the oxygen in your home as combustion air. Stale, humid indoor air is constantly replaced with fresh, filtered outdoor air. This eliminates outdoor pollutants like pollen and soot through mechanical ventilation. And this filtered air reduces exposure to dust and allergens, and especially air pollution that drives high rates of childhood asthma in the neighborhoods that have been historically subject to these pollutants, whether from trucking, bus depots, fossil fuel power plants, proximity to highways, and other sources. And finally, air sealing from the exterior and in between the apartment units drastically reduces indoor pests and the chemicals that are used to control them. So with all of these quality of life benefits, we see how a family can rejuvenate in a clean, quiet, comfortable sanctuary while enjoying the benefits of a low energy home. So these are superior qualities that are unique, that are noticeable, and help to attract and retain owners and tenants to these buildings. So I'm going to introduce the first three projects on this slide and then turn the mic over to Heather to provide a more in-depth study about 425 Grand Concourse. All four of these projects were recently completed and they're currently in lease-up. In fact, as Heather mentioned, 425 Grand Concourse had a really thrilling ribbon cutting ceremony this week, a great milestone for New York City and the Bronx. So together, these four projects make up a kind of like small, medium, large, extra large of multifamily housing in our practice. They range from 7 stories and 185,000 square feet, that's Vital Brookdale, the second from the right, all the way up to 26 stories and 30,000 square feet in the case of Grand Concourse. The EUI for the projected EUI for these four projects is strikingly low. For reference, the average EUI for a New York City apartment building, including existing and new construction, is 87.66 kBTU per square foot per year. So you can really see how low energy these four projects are. I mentioned that the low energy consumption of these projects makes it easy to supply a great deal of the power through clean on-site power sources, such as solar PVs. The 3 projects on the left are all solar PVs, have solar photovoltaic arrays. I'm sorry, they're clearing leaves outside my window right now. It's terrible timing. And so what's interesting about having this solar arrays on the roof is that the amount of roof area really dictates the area for photovoltaics. So Chestnut Commons, which has the smallest array of these 3, you can see it's a 94 kilowatt solar photovoltaic array, has the smallest footprint before Grand Concourse, which did not have room for any PVs on the roof. But that Chestnut Commons project has for the solar on the roof has a payback period of about 9 years. So it's a great investment for those owners. In New York City, building owners are required to provide their renters with heat and hot water as part of their rent. And so choosing high efficiency systems supplemented with solar in New York City makes a lot of sense to reduce costs for those building owners. So Santa Gardens was the first passive house project that was completed at Datner Architects. It was rated under FIAS 2015. This project is 12 stories high and has 249 units, and it's located in the Sound Use section of the Bronx, which is one of those historically polluted neighborhoods that suffered from a real lack of health equity and environmental justice. And so providing these healthy homes that have clean air and are quiet, that are buffered from the elevated train sound and the pollution of the Cross Bronx Expressway is a major benefit to the residents here. But the other interesting thing about the environmental conditions in the Bronx is that, and especially by the elevated train, is that we were required, because of environmental designation on this site, to provide high performance windows to keep out the sound of the train. We were prohibited from putting any kind of openings in the facade, such as for a PTAC or a mechanical exhaust. And this was all because of the noise, which is considered an environmental issue in this site. So by the time we provided high performance windows, eliminated the openings for mechanical systems, we were part of the way there. In fact, a good deal of the way towards a passive house level of envelope design. And so, you know, there's a synergy between dealing with these environmental issues and then consequently reaching to the next bar, which is a passive house project. This building uses a block and plank style of structural system, which means that the bearing walls are made of concrete masonry units, which support precast plank decks, which form the floor and ceiling of each floor. This is an interesting challenge because the facade of the building is also the bearing wall, the structure of the building. And so we were challenged to thermally isolate the exterior. And even though it's part of the structural system, we had to isolate it from the skin of the building so that we weren't losing heat through the exterior. Here's some finished photos. You can see we had a beautiful green roof. Here's a typical kitchen with all electric appliances, the lobby, and a community multi-purpose room that overlooks the roof terrace. Chestnut Commons is a different structural system. This is a 14-story building that uses cast in place concrete columns and decks. This project was in East New York in Brooklyn, and it has 275 units. The ground floor contains a beautiful and really ambitious community facility. The previous project also had community facility and retail at the ground floor. So Chestnut Commons has a kind of a U-shape form, a bit more limited roof area for PVs, but a more common structural system. It had metal stud backup walls with exterior gypboard sheathing. And then the cladding was brick veneer, ephes, and metal panel. I'll show you some photos of the community facility at the ground floor. Here you can see there's a sort of amphitheater style seating area for community gatherings, childcare facility, workforce development, and a training kitchen for a culinary workforce. And then Vital Brookdale at 7 stories and 185,000 square feet is the closest to a mid-rise project that we have here. The form of this building is a little bit different. There's 2 segments arranged around a small courtyard. This project was also in East New York, and it has 160 units. Here you can see in section, this was also a block and a bearing wall and precast plank structural system. This has a pretty ambitious ground floor program with a medical office, nonprofit social services, and a food program. And these photos help show some of those outdoor spaces, the solar PVs on the sort of this foreground building in the upper left. And here in the lower right, you can see there's a sort of a straight bar building on the right side on the lower right photo, and then this sort of L-shaped angled building that together form an open space with a landscape courtyard. So Heather, why don't you take it away for 425?
Sure. 425 Grand Concourse is one of the largest passive house buildings in North America. It's a cast in place concrete structure, 26 stories tall, 311 square feet, 311,000 square feet, and home to 277 affordable apartments. It also houses a 12,000 square foot supermarket, a medical and dental clinic, a community space, public bathrooms for the park just to the north of our site, which you can see here, and a 29,000 square foot space for a campus of the City University of New York. Next slide. Besides being passive house, we've oriented the tower to reduce shading on the park and playground. We have all LED lighting, low flow plumbing fixtures, green roofs accessible to tenants from the 3rd and 25th floors, passive solar shading, low VOC paints and sealants, and all electric Energy Star appliances. One of the reasons passive house made a lot of sense here, and something that Rachel mentioned earlier about some of our other projects, is that this site had what's called a little e designation for noise pollution. So that means we were already required to achieve a high STC rating at our facade for about the lower half of the building. So we couldn't do through wall units like PTAX, and we needed better than average windows. So that really put us on the path to having this high quality envelope. I will say that one of the drawbacks of this geometry is that with this tower, we have very little room for PVs. So there is not any on-site generation at this building. Next. So our air barrier wraps the entire building, but we were able to be a little selective in placing our passive house envelope, which includes everything except the retail space, the public bathrooms, and our generator mezzanine. We were able to work with FIAS on our approach and what would be in or outside of our passive house envelope. And the decision was made to exclude that retail space so as to not place onerous requirements on a potential tenant to use passive house compliant mechanical equipment, which for a supermarket could be particularly challenging. The retail space was part of our whole blower door test, not just for passive house, but to meet New York City building code. And our whole building passed with flying colors. Our CFM 50 for our blower door test was less than half of what was required by passive house. So this is a really airtight, well-built building. Next slide. So what makes passive house a great fit for multifamily is that we're already so efficient in our form factor. A single family home has to insulate at least 4 walls, a roof, and foundation. A single apartment in a multifamily building is well insulated by its neighbors, and it only needs to insulate 1 or 2 exterior walls. Heat rises, so heat loss is most severe through the roof. By stacking our units in a tower, we minimize that square footage of roof area per living unit even more. Here, our form factor is so efficient that we basically have a code minimum insulation on this building. That saves us materials, it saves costs, just makes it very efficient. Each building, each apartment unit has an air barrier between itself and the next, but those air barriers are much easier to achieve without having to deal with wind loads and air pressure changes that naturally occur on an exterior wall. So besides our whole building blower door test, we also did blower door tests for individual units throughout the building to check that airtightness between the apartments. Next. So we're providing filtered fresh air through an active ventilation strategy. And instead of just exhausting air from bathrooms and kitchens, we also supply fresh air to bedrooms and living rooms, which is preheated or pre-cooled, depending on the season, by our energy recovery ventilators. We have a mix of floor-mounted and wall-mounted VRF units. One of our challenges in New York City is that our room and apartment sizes are smaller than the average in the US. So we often have to work with a little bit of oversized equipment. The floor-mounted units are a little bit more efficient in that way because we can serve 2 rooms by just kind of like splitting in either direction. But we also use wall-mounted units as well. It's just a really standard off-the-shelf solution, and it doesn't use up valuable floor area, which again is really critical. So all of this equipment is really standard and easily available these days. One area where we were not able to go all electric in this building was with domestic hot water heaters. In 2018, 2019, when we were finishing up design, there was not an electric hot water heater that could serve a building of this size on the market. So here in this building, we do have gas for domestic hot water, but that market has completely changed in the last couple of years. And now that those units are available, and we're doing electric hot water heaters in buildings where developers want to limit their reliance on gas service, whether or not they're trying to build to passive house standards. Next slide. So Rachel touched on some of these points, but beyond energy savings, Passive House has some really great health benefits for the people living in the building. As you can see here, we have large casement windows for plenty of daylighting. Those windows are operable, but due to the great air quality and thermal comfort and just really incredible quiet when those windows are closed, you never need to open the windows, and people might choose to very rarely open their windows in a Passive House building because there's just such great conditions indoors already. It's kind of one of the striking things when you're on the 3rd floor of an apartment building in the middle of New York City, and it's just completely quiet in that apartment. It's really fantastic. So living through a pandemic, we all know about the importance of air quality. And here we have that filtered fresh air that's constantly being supplied to living rooms and bedrooms. That means outdoor pollution, whether it's from traffic or manufacturing or anything else, and also pollen is not getting into the apartment. So even just people with allergies are going to have a much easier time in this building. They're not having pollen infiltrating. It's one of the things we talk about. A lot of our affordable housing is in neighborhoods that have been deeply affected by environmental injustices in the past and have high asthma rates. So building really high quality buildings with great indoor air quality is really important. Rachel also mentioned that the tight air barrier around the building and between each apartment means that there are less pests, which is just great in and of itself, but also it means less of toxic pest control solutions, which is also really important. You can see in these images, this is our typical studio and 1-bedroom apartment kitchen. We have all electric appliances, so you're not burning gas in the apartment. We're really trying to minimize those indoor air pollutants as well. Next slide. So we also provide amenity spaces which contribute to the health and contentment of building tenants. Here we have a fitness center, 2 community rooms, and 2 rooftop terraces, one of which is on the 25th floor and just has sweeping views of the New York City skyline. You can see across the Bronx, across Queens, all of Brooklyn and Manhattan and New Jersey. It's just really unbelievable. I was at 425 Grand Concourse on Wednesday for the ribbon cutting, and I was just speaking with a mom who was there, who was, with her 3 kids, came to the ribbon cuttings. They're just so excited about the building. Her kids are like 5, 7, and 9, and they live in a 3-bedroom apartment in the building. And she and her husband are so excited about the fitness room. It's so convenient. They can just take turns. They each take a turn in the morning to go down, work out, come back up. And she's just really thrilled to be able to model that healthy behavior for her kids. Next slide. So in all of our projects, we strive to design high quality buildings that will function well for their owners and tenants and minimize their impact on the natural environment. Passive House gives us a systematic way to verify that we're meeting our goals. And because it's performance-based and we do those lower door tests, at the end of the day, we can be really confident that we have a quality envelope. Multifamily housing is already an environmentally sustainable way to build, but by doing this overlay of Passive House, we can make it more desirable for tenants and reap those benefits for years to come. And as we're seeing, local and state governments are setting these goals, 2030, 2050, and they're making regulatory changes that require greater efficiency. And these buildings are meeting those targets today. So they're not going to require deep energy retrofits in the future. Christoph is the expert on, on how this all works out financially, and I'm going to hand it off to him to talk about why Passive House makes so much sense financially.
Thanks, Heather. I'm going to try and share my screen here. Okay, so this seems to work. Yeah, good afternoon, everyone. Again, Christoph Stump with Trinity Financial. We want to look My screen is a little funny here. Do you see this? We wanted to look more closely on what we call a business case for Passive House. Heather just, presented this building. I have a couple more pictures. So this is what we really studied, and what we looked at were what many people would consider extra costs for high efficiency building, and then what are the financial benefits? How can that be financed without hurting anyone? So for that, we're going to look first at the extra costs that are for items that are beyond a baseline case. And there are three major areas that we have looked at. You've heard this before. The envelope, we have to look at that. Then there's a quality control engineering and testing component that is certainly beyond the baseline, as well as the HVAC systems are also slightly different. I'm going to show you the difference to the baseline. Here, I'm starting with the envelope, and I put this chart up so you can see, Heather mentioned this, our envelope is not much different from code compliance, so which I put into the first column here, baseline, so energy code. I want to mention this baseline is really just code compliance. So if you do anything less, you're not legal, So I call this the barely legal approach, and we are just going just a slight step above that. You see roof insulation is the same. Yeah, the insulation is a little more. We almost doubled it, but in the end of the day, the installed value is slightly less than double. Where there is a difference, you see, is on the windows. Our installed effective U value that's a significant step, as well as on the air tightness. As I mentioned, that we did a lower door test, so from the code compliance 0.31 CFM50 cubic feet per minute at 50 Pascal air pressure difference. Our Passive House design was 0.08, but we actually tested at 0.035. So we did a phenomenal tight building, and that takes up a bit that I'm going to explain here. Components that cost a little bit extra are high performance windows. So we are using a UPVC casement windows. They're double glazed, they're not triple glazed. You don't need to do triple glazing in New York. Maybe if you go further north or further inland, maybe. Then you definitely have pretty good glazing. I took a picture of our U values and solar heat gain coefficient. On the bottom left, you see how we are sealing our openings, and that's a massive amount of sealing. If somebody tells you if you do a passive house, you need to install twice as much caulk, that's an understatement. Caulk is the one thing you will not save money on, and that's fine because you end up with a very high quality, very well sealed building. And on the bottom right, it's just our air barrier. We use the liquid air barrier directly on non-bearing concrete block. So we have a very good facade. Then you end up with a good facade, and then your structural engineer, your mechanical engineer comes in and they do everything, trust me, to destroy that nice envelope. So what you need to do is separate out these items, structural items, from from the equipment that's on the roof. You see we use thermal blocks here for the damage. We use thermal separation here on the bottom left for our sunshades. Those are structural components. On the top right, we use AAC blocks for roof wall transitions just to get a nice brick shelf in. Bottom is again a thermal block. So those are some added costs on the envelope. I'm going to go to the next category where we have some added costs. That is quality control, engineering and testing. You see there's a new color on the top left. So apologies, there's a lot here. I'm not going to go into much detail, but this is just one example. We started out with a baseline wall section. You can see that on the right, and our sustainability consultant, Stephen Winters, they saw right away, okay, that windowsill looks a little suspicious to us. We're going to run what they call a therm analysis. They put the components into a program therm, and that's where you get these beautiful rainbow pictures. Heather showed it earlier as well. And rainbows are great, not in therm when the rainbow colors converge in one point. That means that you have a massive thermal bridge, and that is especially dangerous if that is on the wrong side of the air and vapor barrier. You get into moisture issues. So what's the solution? Really relatively minor. It's on the bottom left. We inserted this little green piece. It's called a sill extender that allowed us to make the window UPVC sill a little higher so we can get some overlap to our mineral wool insulation from the facade below. That resolved the issue. Another one is you're spending a lot of time on the facade and in the systems to really make sure that you have a high degree of quality control. That's just some random pages from our facade inspection agency. They looked at every screw, every fastener, fastening depth, screw patterns. You know, they really look at everything. It's amazing. It's a whole Bible that hopefully nobody needs to read, but it assures you that you end up with a very high quality building. And then finally, on the testing side, this is the famous blower door test. So high efficiency buildings need airtight envelopes, and that is being tested with this blower door. You see it to the left. Those are just taped over doors with huge fans, and they pressurize and depressurize the interior, and you can measure, you can gauge how much air escapes any given envelope. So you have this just on one door, and you close all the windows in the building, and that's how you get your pressurization test. Takes a lot of effort, and that costs some extra money. The third category is my favorite one, is HVAC, and I'm showing some pictures about ventilation. We'll start with that. On the top left, this is an energy recovery ventilator, an ERV. It's a huge, largely empty box, and you see there's two ducts and two grills here on the outside. This is the box where exhaust air bypasses, not mixes, bypasses incoming fresh air and transfer thermal energy. On the bottom left is a picture of the innards. You see it's an empty box. On the top, there's a fan that you can't really see. It's one piece of equipment in this box. Bottom left, you see is, I don't know why, these pink filter fabrics that give you the absolutely clean, fresh air. Those are MERV 13 or at least 13 filters, so they catch a lot. And then in the middle, you see this wheel. In our case, so again, we are doing energy recovery. You can do heat recovery. You need to check that out. In energy recovery, you have that wheel. That's basically a honeycomb wheel, an enthalpy wheel that is able to transfer thermal energy from the outgoing airstream to the incoming airstream without mixing the actual airstream. So that's a gadget. We're not going to go into detail. Top right is very important, our constant air regulators. If somebody wants to open their windows to make sure, especially in a high rise, you don't get these stack effects, these automatically regulate air pressure so that you don't suck out the air from a low apartment when you open the air, or vice versa, push out the air from an upper apartment. And then on the bottom right is just a picture of a insulated fresh air duct. Then we're going to heating and cooling. We used a central system, variable refrigerant flow, VRF. Bottom left, that's what you end up having on the roof. So we have it actually on two roofs, on the very top and lower base roof. Each of those condensers feeds one entire floor in the building. So it's relatively little equipment. Bottom right, that's what you end up in the apartments. You've seen this in Heather's photos as well. You see this cassette here on top. There's other ways to do this, but this piece here is just, there's a little fan in there that blows over coils for heating and cooling. We have an energy recovery VRF system, and the top right is a box that enables that. So you can, on one condenser I mentioned, serves an entire floor. So you can, with this system, you can heat in one apartment and cool in the other apartment on the same floor in the same system. It's basically, it turns into a quote unquote a three pipe system that enables that, as it's very important to be able to heat and cool at the same time. And this is the magic box to do that. I'm not going to, and I can't really explain how this works. This is a magic box, that's how I call it. So those are really the main differences. We're going to look at the costs now. So I split it up again in this beautiful chart. On the left, you see the categories again: envelope, QC, engineering, testing, and heating, ventilation, and air conditioning. And I'm not going to read this down. This is just a comparison of the baseline building, double hung versus casement, and exhaust only versus balanced air. So there are these differences. And on the very right side, I'm showing the cost differences. So we tallied this up. We did a full estimate of the baseline building, and obviously we have the actual cost of the actual passive house. So 1.2 million on the envelope, similar on quality control and engineering, and 1.8 million on the HVAC. Turns out total of 4.15 million, or distributed over the square footage of the building, it's $13.35 per square foot. To illustrate this a little better, we put this in a pie chart, and you can see there's a whole lot of pie and a very, very small slice. This is an added cost of just over 2% of the total development cost. It is real money, but it's compared to the project is very minor. So now we're going to look at the other side of the equation. So those were the extra costs. Where does the money come from? And I call that the reverse piggy bank principle. So you spend the money first, and then you save later. So don't tell your kids that, but that's how a lot of this financing works. And how we determined the incoming savings from the operating costs, we used energy use intensity. That's the measure that I think Rachel earlier mentioned. That is a measure of a building's energy consumption per square foot and year. For some reason, kBTU could be anything, could be kilowatt hours. So this works just fine. For the baseline building, we used EUIs, and we're specifically looking at the site EUI. That's the second to last row here. Site energy use intensities. We got these numbers, 82, from the city. The city benchmarks all, or not all, but over 16,000 multifamily buildings every year. So this is the benchmark number. And for 425 Grand Concourse, we are using a site EUI of 32 derived from an energy analysis by Steve Winter Associates. And because the analyses are based on, ASHRAE and ASTM, whatever it is, they're not, not actuals. We have factored that analysis up by almost a third. That's the margin of difference from typical utility analyses compared with the actuals. That's not a fault of the analysis. They have to compare that apple by apple. This is just a reality of actual consumption. And now, if you know the mix of the various energy sources in the building, and we do know these because these are benchmarked. We know, the distribution between gas and electric fuels, and we have local utility rates that we can apply. So we apply local utility rates. Don't read the fine print. You can take a picture or a screenshot, read it later. In end effect, you are paying $346 for the average new construction building in the city per year, and $1.91 per square foot in year at Grand Concourse. So there is a difference of $1.55 per square foot in year that are actual utility savings that you can harness to pay for these initial expenses. The expenses is $480,000 for the whole building. That's not insignificant, and you can just put that into a calculator. Here, I assumed an interest rate of 6%, changes daily, but you have to assume something. And with these $480,000 per year to pay back the $4.1 million in initial added costs, that's a payoff period of 12 years. Might change slightly. Is it instant? It's not instant. It takes a few years, but it's a very reasonable time frame. Now, this is really the super narrow business case. Of course, Passive House has many other benefits. Heather, I mentioned that already. I want to just show this here again. The cost reductions that you have on other areas. I'm just showing health risks for heat-related illnesses. Passive House is a way of building buildings that can withstand heat. Respiratory illnesses, we have filtered fresh air and noise, we mentioned. They are tremendous. And I know this is not strictly business, but if there's a policymaker in this webinar, watches this, you might take note. And it's not abstract. I might put here a few studies out there on the left side. Is a study from Xiao Wu in Science Advances. He looked at the PM 2.5, that's particulate matter 2.5, that's air pollution. In the United States, the browner, the more polluted, and it's a typical pattern that we see. East is more polluted, and plus California, you have all these fires. And you overlay that with the COVID-19 mortality rate he found in 2020. So strikingly, and this is the mortality rate, so these are not absolute numbers. So you can see how it's much more likely that you are much worse health affected by COVID-19. We all know it's a respiratory illness. A similar picture shows on the top right, this is the burden of asthma in children. And so basically it's the same map. Those are millions of children every year. Bottom right is a map of heat-related illnesses. One last, I want to show the really well acoustic performance of a building. This is a map of New York City that U.S. Department of Transportation measured traffic noise. This is road traffic and air traffic. You see the airports are easily identifiable. Our building here is right in, in an elevation of a runway at LaGuardia Airport. And, you look at the increased risk of various hypertension, myocardial infarction and stroke. And you see, you look at, okay, we're at 65 decibels. That's a 10 to 15% risk increase in these illnesses. Those are real costs that Passive House can address. It's not the strict business case, but it's a little outside the box. So I want to encourage to do that and think of all the other benefits. And I think we're a little late, so thank you very much, Scott.
Thank you so much. So, David, do you want to take things over?
Sure. Yeah, I just want to thank you guys again for sharing this with us. It's so relevant to what we're facing right now in Alexandria. And we've got a lot of multifamily housing going up, and this is really inspirational. Let me kick off with one quick question about the finances. Christoph, how much of this would translate out of New York City. I think Rachel, you mentioned I think it was you, Rachel, who said that you're already part way to Passive House because of the noise abatement requirements in New York. But those seem rather small to me. I mean, in terms of the big picture, but it certainly does help you if you've got to do that anyway. But are you all doing projects outside of the city of New York? And is Passive House in your calculations for those projects as well?
Absolutely. We do projects, we mentioned this earlier, all over the Northeast, from Massachusetts, Rhode Island, Connecticut, New York. And Passive House is just it makes so much economic sense that we are doing this in areas where we don't have these co-benefits, for facades, for example, on noise reduction requirements. This is something that makes sense for us. And I think it is very much universally applicable because you can just calculate it straight down from your energy use intensities, and you will find that this you can work with this anywhere.
Good. I'd like to open it up to the audience. I know there will be questions out there, and I think Scott is trying to make that happen.
Yes.
So that you could simply raise your hand and we could recognize you.
John Welsh has a question. John, do you want to go ahead?
Sure. Hi. Thanks for taking my question. Couple of questions related. I think this is going to be really for Christoph. Two questions related to the VRF. One is whether or not there's, compared to your traditional system and equipment, whether or not you have any specialized training for the maintenance staff or need to bring in specialized vendors for the VRF system as opposed to the, I'll say, traditional systems you've used. And then secondly, VRF systems are terrific, but I'm curious how you have managed the utility allowance computation as it relates to a tax credit deal or whatever other affordable financing that you're using, because it kind of inverts or puts more responsibility on the house meter for all the pumps and everything.
That is correct. So 2 parts, right? Maintenance. Yes. So our building staff needs to be trained on the system. You're using a computer to moderate the system or to manipulate the system, and you're not going to a PTEC in somebody's apartment. So there is definitely this, and I'm not saying that VRF is the best possible way out there. It made the most sense on our project. There are many other heating and cooling systems that could work for other, you might find that you go through an air heating and cooling system that are very efficient, and you package it all into one unit. We decided against it because we think that the VRF system, and we have done many VRF buildings over the years, they are relatively simple to maintain. The other question on affordable housing, this is an affordable building, and you're right, it gets quite complicated. Now, not every building is affordable, so I make a case that applies to any high efficiency building, because you look at the full building and not at individual meters. And this is also something that every building has to look at. What are the requirements for affordable buildings? In our case, it's the landlord pays for heating and for hot water, but not for cooling. It is complicated. We are sub-metering the cooling loads and bill tenants separately for it, and it works better and worse. It really depends, but the loads on a passive house are relatively minor, so it's not a huge burden if not everybody's, if you have collection issues. The other part that I would look at, this system, VRF system, you mentioned it, most of the loads are on the house meter. You have a commercial rate, not a residential rate. So the actual utility rates are significantly lower. That's also a big benefit. And then, you know, if you use a different system, you have it differently metered. So our heating and cooling is not all on one meter. It's the house meter takes most, but then we have all these tenant meters that take part of that heating and cooling load just for their fans. You have these in-unit evaporators, and they are on the tenant meter. And every system is different, and you can't, you know, you have to look at every building. But I think ideally we should be looking at the full building and make it work with one house meter for heating, cooling, and ventilation. That's ideal for also for underwriting purposes, because then you have cost certainty.
I'll add that we're also seeing start to move towards a right to cooling, especially, you know, as our cities warm and heat-related illnesses are on the rise. We mentioned that New York City landlords are already required to provide heating as part of the rent, included, you know, landlords pay that. And I imagine that we will see local legislation before too long that requires cooling to be provided as well as a health equity and just a health issue in New York City. So having these, what we would think of as 2-for-1 type machines, you know, heat pumps that can heat and cool homes, is a way of future-proofing and avoiding energy retrofits. So VRFs, or I should say, you know, heat pumps in general, whether it's air source or ground source heat pump, are an ingenious technology for heating and cooling, and something we should be moving towards in all of our projects for, you know, multiple reasons.
And let me add like one little extra thought there. Our VRF is an energy recovery system. So apartment A is heating, apartment B is cooling at the same time. That means that there is no ask for the condenser on the roof. So how are you dealing with this equitably? Everybody saves money here because we're just moving around energy. We're not using the heat pump. So this is another reason to go central with heating, cooling, and ventilation.
Great. Did you have a follow-up to that, John? I guess not. One quick question about the that we hear sometimes from developers in our area about the interior air quality issues in passive houses in multifamily buildings, where you may have a lot of cooking with deep frying and cooking with lots of steam, creating lots of humidity. Is that affect your calculations in passive house construction? Can you comment on that, I guess?
We haven't had problems with cooking. Yes, humidity is an issue and needs to be carefully modeled. And I encourage folks to work with the modeler to really adjust your expectations of the actual use. When you go straight with ASHRAE and ASTM, you have an occupancy load that's not realistic for affordable housing. We have small apartments, and we know, you know, your cousin might be sleeping on the couch for an extended period of time and taking extra showers. You have, you know, pets and plants. Those are all additional humidity emitters that you need to really be careful about, but that can be handled.
Good. Rachel, this is a question to you, just sort of a general interest question, and that is, how is your professional work doing high performance buildings connected with your role as a city official? How does that affect your thinking as a city official?
So in my relatively small town, being a council member is a volunteer position, and it's one that I cherish because so much of what we do in local government pertains to land use, development, In our case, the energy transition, because we have our own electric utility in my town. And it's been exciting to be able to advocate for standards such as Passive House. We are constructing, or we have a municipally sponsored affordable housing project that's in construction now. It's 44 units. And, by having someone on the council and then later on the Affordable Housing Committee with a focus on design, who could speak knowledgeably about Passive House and energy standards, it really helped us to advocate with the developer that was selected for this project to reach for that high bar of Passive House. This was, we put out an RFP for this municipally sponsored project, and we had a number of respondents. And, being an advocate as an architect and someone who's passionate about climate, and translating that to how we can make positive choices for the built environment in our cities, it's a great sort of synergistic way to take my personal and professional experience and put it to use as a volunteer locally. It's also helped me understand a little bit how, in New Jersey, for instance, we can't have local building codes that are more stringent than the state building code. However, if we have an area where we have put out an RFP for development, we can set criteria for the selected developer, such as energy standards, and we can incentivize by offering, for instance, a floor area bonus for particularly high performance proposals. So this has given me, a bit of insight into how local government interacts with developers, how we can make choices about land use, and how we can educate our residents and the people that we do business with about these important issues. So it's been really gratifying to be able to take that experience and that passion and put it into, this volunteer role in my town.
Thank you. I think we have a question from Kathy Hoekstra, and that would be who's a city official in Alexandria. So a volunteer city official like you. And if we can unmute Kathy.
Well, I can just read the question.
Okay.
I'm afraid I might screw up the whole muting and unmuting thing. But she typed, how might you encourage Passive House for developers who build and then immediately sell, and so they aren't interested in waiting 5 to 12 years for a payoff?
Yeah, that is for me. That is true. So we do hold onto our buildings, so we have the benefit right away. And what we can do is show appraisers and lenders how we can underwrite these extra costs, so you can actually pass on the benefits, and you should be able to get a higher sales price for this, right? Because you can generate more operating income. That would be my direct answer. This doesn't need to be a marketing gadget that you're the greenest building and the healthiest building. You can go straight just to the money and make that argument right there. You don't need to hold on, although it does help, because then you assess your own risk, right? But you need an appraiser who understands that.
I was going to say there's a new certification now called Pearl certification that takes those energy savings and helps to standardize it into a line of data for the MLS listing, right? So there's this idea that we need to, when you go to Zillow or Redfin or whoever, and you see the stats about a property for sale, there's a growing consensus that we should be able to understand energy costs and translate high efficiency buildings into value for the homeowner. So I think that is going to be coming online quickly, especially, urged on by the measures in the Inflation Reduction Act, and people are going to be investing in their homes, and they're going to want to be able to show the value for that. And I think that'll carry over to commercial as well.
I think we have a question. I think we have a question from Stephen Koenig.
Yeah, I can read that. I can also answer that, by the way. So on Grand Concourse, that Daphna's slide showed an EUI, a PEUI. Very good, you paid attention. P is for projected energy use intensity of 22.4, and I'm showing an energy use intensity of 32. the difference, I try to explain that on the way, is the PEUI is coming straight from the utility analysis. That is, is what Azure and ASDM tells you to do. My markup of 30% is the markup of an average discrepancy of these utility analyses with our other VRF high performance buildings. So I feel as a developer, I can take what the consultant models and shows me on the analysis. I have to be conservative and look at my past experience.
I think we have one more person in the queue. Matt, do you want to go ahead?
Sure. Can you hear me?
Yes.
Yes, great. This is a question just for the general team in terms of finding the contracting teams for, say, MEP, mechanical, envelope, any special systems that you plugged in for the Passive House certification or that level of building. We in the DC metro area have some challenges finding the right teams to deliver that. Is that something that you kind of assembled over time, finding kind of pre-selected contractors that get what you're trying to do? Thank you.
I can speak to that as well. You are right. For that building, we used a contractor who has experience with that type of construction. I would say, though, that I think a contractor that you feel very comfortable with regards to quality control can do these things. There's nothing magic to it. It's been done very often, but a contractor who does not pay attention to quality control and you don't have your own quality control system in place, that's going to be hard. But I agree. So you get a quality building, you need a quality contractor.
Great.
We have some clients, most of our nonprofit clients especially are not looking to be the guinea pig. They don't want to be bleeding edge. They want to work with systems and standards that are proven. They don't want to be experimentalists. However, some of the projects we shared today were the first Passive House project for that builder. And there is a trend now where as more and more developers seek a Passive House building, more contractors are willing to, get certification, the trade certification with a focus on things like air sealing and airtight construction in order to compete for those jobs. And there is now a kind of tipping point, I feel like, where we have more builders that are willing to some extent, learn on the job, which is going to be part of uptake for, a high quality product, especially in the affordable sector. But there's an incentive to do so. There's, third-party testing and verification that's required. And with good sequencing and planning, doing the mock-ups and doing the blower door tests, testing, unit by unit and then floor by floor before you get to the building, you can catch those sort of learning curve type issues in construction. And of all the projects we've done, we've never had a fatal flaw where in the end the building could not meet Passive House standards because, part of the commitment of Passive House is coordinating the project, both the design and the sequencing and construction from the beginning. And if the team commits to that early on, as Christoph says, it's very achievable.
And Matt, I should add, it's a very important component is probably having a contractor on during pre-construction and really tell you, I can do this detail, or I can do a different detail that works with my specific subs or sequence of, installing things. So that's, if you completely design and then blind bid and pick the, least expensive contractor, that can be difficult.
I would just add on to what Rachel said that about FIA's Passive House Institute. They really want you to succeed, and they're having them on the team, I think gives the owner a lot of in that concerning, well, I'm doing something I've never done before, because that's third-party verification of all your details and of everything that you do. They're on your team, and projects that really helps the clients and helps us and the builders. Scott, should we, I think we're probably at our time.
I think so. Maybe a little bit over time in some respects, but it's very, very helpful Q&A. Very much appreciate the presentations. This has been a great learning experience for us. So thank you very much. I'm not sure how doable it is, but a virtual round of applause for our panelists. If we could do that. Thank you, Rachel, Heather, and Christoph, very much.
Thanks for having us.
Yeah.
Thank you.
Have a good rest of the day.